Welcome back to my channel, and today we're going together solve the daily LeetCode problem. And so for our today problem, we have the problem from the weekly contest. Then this problem is quite interesting, I think so. And yeah, so in here like I use an example for us. Indeed, this example I got this example that as my mistake, and then so yeah, it make me to change my approach, and I hope that it is useful for us. Yeah, so for it now, for this example, for this example, and then we are given an like array of the element ones and the fives, and in here like we are given the k equal to 3 as well. So firstly, if we just like visualize everything in the x-axis, I mean like the horizontal axis, and then we can see that like that is the 1 here, and also we have the 5 here. Okay, so for each number, and then we can construct a lot of the elements from the central. For example, this one is for the 1, right? And in here like we can construct k numbers. In here also we can construct k elements as well. And then we also need to plus the middle one, so that is a reason why in here for any kind of the given number in the array, and then we can construct like 2k plus 1 elements. Okay, however, like in here we have some problem. Let's say that in here like the frequency of 1 in here, that is 8, right? So it, however, like in here we can construct 2k plus 1, which is 7. So it means that like for the one with the frequency of 8, and then at max we only can construct the 7, and then we just from here we can see that like the number of the distinct element can be created by a given number in the array, that is the mean, right? That is the mean between its frequency and also the 2k plus 1. Okay, so in here it means that like for any kind of the given number in here, and then we can enumerate how many kind of the elements it can construct, right? Yeah, so the problem arises when we have some kind of the intersection between the two consecutive numbers. For example, like in here, two consecutive number, in here like I mean the unique number. For example, in here we have 1 and 5, right? We don't count how many kind of the repetitions for the 1 and 5. In here we can see that the upper bound of the 1 is 4, and the lower bound of 5 is 2, right? And then we expect to see the intersection between them here. So the intersection in here we have 3 numbers, so that is equal to 2, 3 and 4, right? So that is 3 numbers in here, and then this is the intersection between two consecutive numbers in the array. And then so somehow like in here, if we can calculate this one, let's call this one as the capacity, as the cap, right? And then somehow like in here like we have some kind of interval region, and then we need to calculate how many kind of the elements we can construct from these things. Yeah, firstly we can see that like in here for we have the 7 number of the elements 1, right? So it means that the all of the element ones, it will acquire all of the region here, and then it means that also it acquire the overlapped region, and then so in here we have the 5, and then let's say that like we also define something called the flexibility. So why that's called the flexibility? Because we have the case in here is that because in here we only have the 3, 5 numbers, and then somehow like we can move all the 3, 5 numbers to the right, and then to accommodate for all of the numbers created by ones in the overlapped region. And so how can we calculate the flexibility for each number? So in here, for example, in here we have the capacity of the, I mean like totally we can create 2k plus 1 numbers, right? And then in here the capacity of each one, that is only the things like the mean between the frequency and the 2k plus 1, right? And in here that would be the mean between the and then we just need to minus to the capacity, And then in here, so you can see that like the capacity of 1 is 0, and then that is for the 1. How about the capacity of 5? So in here we can see that the frequency of 5 is 3, and then so we can have the flexibility of 5 in here, that is 2k plus 1, that is 7, and it will minus to the 3, right? And then that would be 4, and then this one is for the number 5. So we can see that in here we have only 3 elements in the intersection, and these 3 elements can be accommodated by using the capacity of 4 from the 5, right? So we can see that in here, if we just like move all of the things in here, we still have one more slot in here, and then so we can use this one to accommodate to the future values. Let's say that we have another value here, right? Okay, so that is the things and how can we calculate. Let's say that we can have the capacity from here. We can accommodate to more of the numbers in the future. We do so on and so forth. Okay, so it means that they like from here, so how can we update the capacity? Because like in here we own how can we update the flexibility? Because in here the 5 is use the 3 slots to accommodate for the elements in the overlap region created by the number ones. So it means that like in here the capacity in here is that like the intersection in here we have 3, right? And the total flexibilities between 2 consecutive value, which is 1 and 5, that is 0 plus 4, and then what is the number we can accommodate? That is 3, right? And then it means that like the remaining flexibility for the 5, that is only the 1. Okay, so in here like you may ask me that like how if we just have the things like, what if in here we only have maybe we have 3 elements of 1, right? And then we have 3 elements of 5. It means that like we can move all of the element ones, the number created by ones to the left, and then like we can accommodate all the things for the overlapped region, and then we keep the flexibility of this 5 intact. Okay, so that is very good questions. And then so we can see that in here we can have the update rule in here is that like so the update rule in here, let's say that we are updating for the 5, and that would be like the mean between the flexibility of this one, right, for the capacity of current value. And then so we can see that in here the flexibility of the previous one, flexibility of the previous one, that is I minus 1, for example. And then so how is the flexibility of the previous one? In here we have 3 elements. It means that like the capacity of this one is what is the 7 minus 3, right? That is the 4. And then so here like we have 4. Okay, so plus the current one, that is the 3. It means that f of I, flexibility, right? And the current one is 4, and we just minus this one, that is the 3. So we can see that like in here this one will result in the 4. Well, it means that we keep all of the flexibility of 5 intact. And then let's say that we add one more here, and then we increase the frequency of ones, and then so somehow like we can see that in here like this one is just like that this one will be modified as 3, and here that is 3, right? And then we still have 4, right? So what if the flexibility of this one is just another one? It means that like flexibility of this one is 2. What if this one is 2? It means that we only have 2 empty slots to accommodate for the new elements. And then so somehow like you need to sacrifice some of the elements from here to the ones, right? And then so somehow in here like we have just we can update this one as 3, right? So in this case like we can do the same thing for the future value, and then so we can we can do it iteratively, and then we can get the result. And so in here like we can see that like we need somehow like we need to calculate this region as well. And then so we can see that this region, what is the number 4? Number 4 in here, what is the number 4? How can we get the number 4? And how can we get the number 2? So number 4 is what? Number 4 is the nums I, right? And then minus k. And then so it means that like, that is a 2. So here is like, we will calculate the upper bound first. That is the num I. Num I minus 1, right? That is the bound for here. And then we plus k minus what? Minus the 2 in here, that is the num of I minus 1. And then this one minus k, right? And because of enumerate, and then so we plus 1. So this one we can transform to the 2k plus 1 minus plus the this one is I, sorry, right? I here is the 5, I here is the 1, right? And then so here like that is the plus the n of I minus 1 minus n I, right? Okay, so that is the things we can update in here. It means that we can calculate the overlapped region. Yeah, so from these things somehow like we can program it. Yeah, so I mean that like just this is just my approach, and then of course like we have a maybe simple approach. Yeah, let's define the hash map, which is equal to the counter of the nums. And for this one we will do the things like we will iterate through the key and the value in the HashMap dot the items, and in here like we can update the value of the HashMap because we know that like the maximum value is just like 2k plus 1. So it means that like we will have something like the capacity, it will be equal to the mean of the value and the 2k plus 1, right? And then so in here like we also have the flexibility for each each number. That would be just like the things like that is the 2k plus 1 and minus the capacity. Okay, so we have it here. And then so for now we just need to iterate through the key, right? And then we have the keys that is equal to the, we will get the list of the HashMap dot keys. All right, so yeah, we just have the things in here because like we will sort in order because that is the interval, so we don't want to like mix it up. And then so by sorting, and then we can make our problem become easier. So in here like we get the key dot sort. Okay, so yeah, so for now we define the distinct number that is equal to 0, and then so we will iterate like yeah, range length of keys, we iterate from here. And then so like we get the intersection first. And what is the value of the intersection? The value of the intersection we calculate from here, right? So that is 2k plus 1, and then it will plus with the keys of I, and then it will minus the keys of I minus 1, right? So this is just 1 2 3 4 5, and then that is the number in here but without the repetition. Yeah, so in here like we can have the case like if the intersection if that is smaller or equals than 0, it means that we don't have the intersection, and then we just safely like get the distinct number that will be added up with the hash map of the keys of the I, right? And then we get the first element, because like the first element in here we defined it as so in here the hash map of the key will be equal to the capacity and the flexibility, right? Okay, so we can have two numbers. So in here like we will add the capacity, and then after we add the capacity, if the intersection is like, if that is greater than 0, it means that we actually have the intersection, and then we need to deal with this case. And for this case, we can like update the flexibility between two consecutive numbers. So flexibility, that will be equal to the hash map of the keys of the I, right? I mean, like in the previous one, that is like, and the flexibility is the index one, right? And also we need to consider the current one, that is the key of I, and then we get the one. So in here, like, that is the total flexibility we can have. And then if the flexibility, right, if the flexibility, if what if it's smaller than the intersection, right? If that is smaller than the intersection, so it means that like all of the flexibility we have is not able to adopt all of the created elements between two consecutive values. It means that like in here we get the distinct, that would just be updated by the hash map of the current one, current key I, and then so in here like we get the 0 as the capacity, right? And however, this one need to be minus the intersection, and then this one will be minus the flexibility, right? So yeah, so it means that like we cannot adopt to that. And then however, like in here we still need to update the we need to update the flexibility of the current one as well. So here the flexibility of the current one, so this one would be have the problem of index, this one as well, key 1, and this one is 0, it be equal to 0. And then so here we can see that like otherwise, like what if the flexibility will be equal or or greater than the intersection, right? And that one would be like we safely add all of the things created by the next of the current element of the keys of I, and then we safely add all the things in here. However, like we need to add update the flexibility of the current one I, and then this one is 1, and then so we update by using this one. And then so how can we do this? And then that would be the mean of the like the current one, hash map of the keys I, and then we get the first one, right? And then this one we will get the flexibility, and then minus what? Minus the intersection. So here like it is because of like we can see that because of the flexibility is greater than the intersection, so we safely just get the flexibility minus the intersection in here. That would be like it will result in the maybe greater or equal to 0 value. So here we can just like, yeah, so I think that's all the things we need to do, and then we just need to return the distinct. Yeah, so let's see, maybe something wrong in here. Yeah, so in here I think that like one things we have in here is that distinct will be equal to the first one, that is the hash map of keys 0, right? Yeah, key 0, and then so we get the 0 here, intersection in here. So the intersection in here, that should be like the plus the a minus 1 minus the num of the key. So in here like we have like this one is the plus and this one is the minus 1. Yeah, so let's see. Okay, it works, and then just submit. Alright, so I think that this problem is like it's good, and however like I don't think that my approach is like optimized enough. And yeah, so I think that is the room for you guys to like optimize this further. And yeah, I just want to share my approach because I think that it is quite like interesting, and maybe it is like intuitively understandable. Yeah, so yeah, again, thank you so much for watching my video, and see you next time.